Today's focus will be on two of the exponent rules, mainly the product rule and the power rules. So after completing your first two pages on your packet, you should have pretty much seen these two rules in action. So the product rule tells us that when you multiply monomials, meaning two individual x terms with a power, and if they have the same base, meaning they both have the letter x or they both have the same number, you add the exponents. So we've seen this rule before. And all we do is just remember, add the exponents. If you ever forget the rule, just expand it and then count, and you'll see it's just an addition. Second rule is the power rule. So when you raise something to another power, meaning you only have one single base, so you don't have a base times another base, you have one single base, in this case just the letter x to the power of m, and that's multiplied to another power, and you just multiply the exponents. So here we have an example of each of these cases. So example 1 and 2 shows the product rule. Again, we add the 1, the 3, and the 4 to get 8. On example 2, we add the power of 2 and the power of 3 on the x's. We add the power of 1 and the power of 4 on the y's, and we just multiply the regular full-size numbers. Examples 3 and 4, again, that 4 that's raised to the power of the ones we already have, that gets multiplied to the 2 and the 3, which gives us 8 and 12. The 3 power on example 4 gets given to the 2, so we get 2 to the power of 3, x of 3 times 3, y to the third, because it had an invisible 1 to start with, and 2 times 3 for this one. Just be aware when there's no power to begin with, we just put that exponent given to us. And then we end up simplifying to the following. So the 8 comes from 2 to the third power, meaning 2 times 2 times 2. Just one side note, one thing we always want to remember is an exponent applies only to the factor it is directly next to, unless there's parentheses. So what I mean by that is the following. Let's say I have 2 times 4 to the third. The third power only belongs to the 4, not to the 2. So it's not that they both have a power of 3. It's just the 4. So that's why I said it's directly next to the 1 you have, unless there's parentheses. So if we had the following, 2 times 4 to the power of 3. In this case, the power of 3 belongs to both the 2 and the 4 because the parentheses indicate it as so. So back to the previous one, the 2 only has an indivisible power of 1, whereas the second one that has the parentheses on it, the power of 3 belongs to both. So let's go ahead and see a few examples of this now. So we're going to start off by taking our table and we're going to write it in two forms. So directions on today's notes will be using these, either write something in exponential notation or to evaluate, which means just to figure it out. So here we have it in expanded form. An exponential notation is where we have one base, one power. So in this case, we have the base of 3, the power of 4. For the next one, we have the base of -4. And because it's negative, we have to use parentheses to the power of 3. There's 1, 2, 3. Next one, we have -2 as our base. Use parentheses since it's negative to the power of 1, 2, 3, 4. Next one, we have 2/3 as our base. It's a fraction, so since we also have a fraction, we always use parentheses for these as well. And that's to the power of 2, since we have 1, 2. Next one, we're working backwards, so we have -5 to the power of 2. That means -5 is being multiplied twice to itself. Next one, we have -5 squared. Again, this one does not have parentheses, therefore it's different than the previous one. That means we are multiplying the number 5 2 times, and there just happens to be a negative in the very front. So the -5 is not being squared. There's no parentheses to indicate that. So let's go ahead and evaluate these. 3 times 3 times 3 times 3 for the first one. We have the first two 3's give us a 9. The next two 3's give us a 9. So this just ends up being 9 times 9, which is 81. The next one we have 4 times 4, that's 16, and two negatives become positives, and 16 times 4 will give us 64, but it's negative. So 3 negatives stay a negative because 2 cancel to a positive. Next one we have 1, 2, 3, 4 negatives. Every 2 negatives makes a positive. That means our answer is positive. 2 times 2 is 4, 2 times 2 is another 4, and 4 times 4 is 16. Next one, when we multiply fractions, we multiply the numerators and the denominators. So 2 times 2 is 4. 3 times 3 is 9. I cannot reduce this fraction, so it stays as 4/9. Next time we have a negative 5 times the negative 5, which gives us a positive 25. And last one, 2 5s make 25, but we have a single negative, so it stays negative 25. Go ahead and answer A, B, and C. So pause your video, answer them, and we'll come back to it. All right, now that you've completed A, B, and C at the top, how would you write negative 3 squared in expanded form? You should have the following, negative 3 times, in parentheses, times another negative 3. That's in expanded form. How would you write negative 3 squared in expanded form? That would be formed negative 3 times 3. So explain whether or not these are equivalent, meaning equal. So are these equal? The answer would be no, because the top one is equal to positive 9, and the bottom one is equal to negative 9. So we'll say no, since 9 is not equal to negative 9. All right, let's go ahead and work on A through F. Let's go ahead and read the directions to see what they're asking us. So let's just rewrite each as an equivalent expression in exponential notation. So one base, one power. So they have the same base, 5. The rule is we take the 6 and the 9, and we go ahead and add them, which is just going to give us 5 to the 15th. Next one, we have negative 8. We have parentheses. We have to make sure we keep them. We have 5 plus 3, and that gives us negative 8 to the 8. Next one, we have 1/3. We keep our parentheses, and that's 8 to the 8 plus, here we have an invisible power of 1, so we add that 1, so that's going to be 1/3 to the power of 9. Next one, we have x. This time we're going to skip it. 3 plus 7 is 10. Next one, we go ahead and multiply this. We're going to add all the exponents. So 3 and 4, we don't add them. We just multiply them. They're regular numbers. That's going to give us 12. M to the 4th and m to the invisible 1. We add the powers. That's going to be 5. M to the 7th and n to the 3. We add the powers. That's going to be 10 for our power. P to the 5. Again, there's no other p, so that one just drops at the end. P to the 5. All right, let's go ahead and move on to the last one. We have a negative 9 and a 2. Those are regular numbers. We multiply them as regular, 18. The x's, we combine them by adding the exponents. 6 and 2 gives us 8. The y's, we add the powers as well. The first one has an invisible 1, so we add 1 and 5, we get 6. So this is how we rewrite using the rule. So let's go ahead and move on to the next one. We're going to use those rules to determine if the following G and H are correct statements. And we're going to show the work and support our answer. So let's look at the first one. Is 3 squared times 9 equal 3 to the 4th? Yes or no? So let's just go ahead and rewrite the 9 as a power of 3. So I'm going to leave this as 3 squared. 9 is the same thing as 3 squared as well. Now the question is, does that equal 3 to the power of 4? While using the rule, 3 is 2 plus 2, and 2 plus 2 is equal to 4. So the answer would be yes. So I've shown that the left side is equal to the right side. Let's go to the next one. Is 8 times 2 to the power of 10 equal to 16 to the power of 10? So let's go ahead and rewrite all of these as powers of base 2. So the 8 would be 2 multiplied 3 times. So it's 2 to the 3rd. Times 2 to the 10th. And if we add 3 and 10, we get 2 to the 13. How about the right side? Let's look at the right side, 16. Well, 16 is the same thing as saying 2 times, well, actually I'm doing 2 more steps. 4 times 4. And that's 2 squared times 2 squared, or just 2 to the power of 4. Sorry, we got to add it. So this is 2 to the power of 4, and it's all to the power of 10, and the rule is we multiply these, so 4 times 10 is 40. So my answer here would be no, because this is false. So let's do some side work here. So let's go ahead and move on to the next piece. All right, we're going to rewrite each one, and again, using exponential notation. This time we're going to be using the power rule. So again, this is just 5 to the power of 6 to the power of 9. So double power. So instead of adding 6 plus 6 plus 6 plus 6 many times, it's easier just to do 5 to the power of 6 times 9, which is just 5 to the 54. Next one is negative 8 to the power of 5 times 3, or just straight to negative 8 to the 15th. Again, eventually you will be skipping that middle step. If you want to start skipping it now, that's fine. Next one is 1/3, 8 times 4, which is just going to be 1/3 to the 32, or 32nd power. All right, next one, x will be 7 times 3 is 21. Next one, we have x squared y to the 6th power, so that 6 gets given to both of them. So we have x squared times 6, so 2 times 6 is 12. The y has an invisible 1, so it'll be y to the 6th power. Next one, we're going to do the same thing. So we're going to have x to the 5th times, so we got to start with, actually we got to start, and be careful, we got to start right here. So let's start off with that piece because we got to work inside out. So it's x to the power of 10, because 5 times 2 is 10. Y to the power of 8, because 4 times 2 is 8. And we have x to the 6th, and y, all of it to the power of 2. So at this point, I can multiply everything by 2, or I can add the 10 and the 6 on the x's, and the 8 and the invisible 1 on the y. So I'm going to just work on the inside. It works both ways, though. So x10 and x6 gives me x16. We add those. Y, 8 and invisible 1 gives me 9. And all of this is still to the power of 2. Now I'm going to multiply 16 times 2 and 9 times 2. So it's x to the 32nd power and y to the 18th power. And I'm done. All right, last two problems, F and G. Tell whether the statement below is correct. So let's go ahead and see this. The rule here is, do I add the 5 and the 7, or do I multiply them? This is a power to a power. That tells me I multiply 5 and 7, which is 3 to the 35. And that is not equal to 3 to the 12, so that's false. So the answer is no. Let's look at the last one. We have 2/3 to the power of 2 to the power of 4. Let's go ahead and multiply our 2 times 4. That gives us a power of 8. Question, is that equal to 2 to the 8th over 3? And this 8 is given to both, since they're both in the parentheses, so this is 2 to the 8 over 3 to the 8. And that equals 2 to the 8 over 3. Again, these are not equal because the right one has an exponent of 1, where the one on the left has a power of 8 on the 3. So this is going to be another no, not equal. So they're not equivalent. All right, that's just a few examples. Go ahead and start with your practice. Good luck.